Imagine for a moment that you're standing outside on a clear night, looking up at the stars. Thousands of glittering points of light surround you, and you know that each one is a sun, possibly with its own family of planets. Now imagine that around one of those distant stars, someone else is looking back at you, wondering the same thing you are. Are we alone? This question has haunted humanity for generations, but here's what makes it truly unsettling. According to our best scientific understanding, we shouldn't be alone. In fact, the universe should be absolutely crawling with intelligent life. So where is everyone? Today, we're diving deep into one of science's most profound mysteries. And by the end, you'll understand why the silence we hear when we look to the stars might be the most terrifying sound in the universe. Let's start with the sheer scale of what we're dealing with. The observable universe stretches approximately 90 billion light years across. To put that in perspective, if you could travel at the speed of light, which is about 186,000 miles per second, it would still take you 90 billion years to cross from one side to the other. Within this incomprehensibly vast space, astronomers estimate there are at least 100 billion galaxies. Each of these galaxies contains anywhere from 100 billion to 1 trillion stars. We're talking about numbers so large they become almost meaningless to the human mind. If you tried to count all the stars in the universe at a rate of 1 per second, you'd be counting for trillions of years, far longer than the current age of the universe itself. But here's where things get really interesting. For most of human history, we could only speculate about whether other stars had planets orbiting them. We knew our sun had planets, but what about all those other stars? Were they alone, or did they have their own solar systems? In the last few decades, thanks to advanced telescopes and detection methods, we've answered that question definitively. Planets are everywhere. They're not the exception, they're the rule. Nearly every star we've studied has at least one planet, and many have multiple planets in orbit. This discovery has revolutionized our understanding of the cosmos. We now estimate there are trillions upon trillions of planets in the universe, and a significant portion of these exist in what scientists call the habitable zone, that perfect distance from their star where temperatures allow liquid water to exist on the surface. Water, as far as we know, is essential for life. At least, it's essential for life as we understand it. And if planets in habitable zones are common, and water is common, and the basic chemical building blocks of life are scattered throughout the universe, then logically, life itself should be common too. This is where our intuition starts to clash with reality. We have all the ingredients for a universe teeming with life, perhaps even intelligent life that has developed technology, built civilizations, and ventured into space. Yet when we look out into the cosmos, when we point our most sensitive radio telescopes toward the stars and listen for any sign of another technological civilization, we hear nothing but silence. This contradiction between expectation and observation is what scientists call the Fermi Paradox, named after physicist Enrico Fermi, who famously asked during a lunch conversation in 1950, "Where is everybody?" Before we explore possible answers to this question, we need to narrow our focus. While it's mind-boggling to think about life elsewhere in the universe, we need to be realistic about what we can actually detect or reach. Everything beyond our local group of galaxies, which includes the Milky Way, Andromeda, and about 50 smaller galaxies, is essentially unreachable due to the expansion of the universe. Space itself is expanding, and distant galaxies are moving away from us faster than light could ever travel to reach them. Even if an advanced alien civilization existed in a distant galaxy and was trying to contact us, their signals would never reach us, stretched and redshifted into oblivion by the expanding space between us. So let's focus on what's within our cosmic neighborhood, our home galaxy, the Milky Way. The Milky Way is a barred spiral galaxy containing somewhere between 200 billion and 400 billion stars. Among these stars, astronomers estimate there are roughly 20 billion that are similar to our Sun. These Sun-like stars are particularly interesting because we know at least one Sun-like star, ours, has a planet that harbors life. Recent observations suggest that approximately 20% of Sun-like stars have an Earth-sized planet in their habitable zone. Let's do some conservative math here. If we take 20 billion Sun-like stars and assume 20% have an Earth-sized planet in the habitable zone, that gives us 4 billion potentially habitable planets in our galaxy alone. Now, let's be extremely conservative and assume that only 0.1% of these planets actually developed life. That still leaves us with 4 million planets with life in the Milky Way. But we need to add another dimension to this calculation: time. The Milky Way galaxy is approximately 13 billion years old. For the first billion or 2 years after its formation, conditions were probably too chaotic for life to take hold. Stars were exploding as supernovae, intense radiation was everywhere, and heavy elements necessary for rocky planets and complex chemistry were still being forged in stellar furnaces. But after this tumultuous period settled down, roughly 11 billion years ago, the first truly habitable planets could have formed. Compare this to Earth, which is only 4.5 billion years old. This means there was a window of approximately 6 to 7 billion years, during which life could have emerged on other planets before it even started on Earth. Think about what humanity has accomplished in just a few thousand years of recorded history. We went from using stone tools to splitting atoms, from sending smoke signals to transmitting information instantly across the globe, from being bound to Earth's surface to landing on the Moon. All of this happened in a cosmological blink of an eye. Now imagine a civilization that had a million-year head start on us, or 10 million years, or a billion years. What could they accomplish? This is where the concept of civilization types becomes useful. Astronomer Nikolai Kardashev proposed a scale to classify hypothetical advanced civilizations based on their energy consumption. A Type 1 civilization would be capable of harnessing all the energy available on its home planet. This includes solar energy reaching the planet, geothermal energy from the planet's core, and all other energy sources. Humanity currently ranks at about 0.73 on this scale. We're not quite there yet, but we're approaching Type 1 status. Most estimates suggest we'll reach Type 1 capabilities within the next 200 to 300 years, assuming we don't destroy ourselves first. A Type 2 civilization would be able to harness the total energy output of its home star. This sounds like pure science fiction, but it's theoretically possible. One proposed method is the Dyson sphere, a megastructure that would completely surround a star to capture its energy. While we're nowhere near building such a thing, the physics doesn't forbid it. A sufficiently advanced civilization with access to the resources of multiple planets and asteroids could potentially construct such a structure over thousands or millions of years. A Type 3 civilization would control the energy of an entire galaxy. Such a civilization would be so far beyond our current level that we'd likely perceive them as godlike. They would have colonized countless star systems, commanded energies that could reshape space and time, and possessed technology that would appear as magic to us. Here's the crucial point. If even one civilization in the Milky Way's history had reached Type 2 or Type 3 status, we should be able to see evidence of their existence. Megastructures around stars would create observable signatures. A galaxy-spanning civilization would leave marks on the cosmic landscape. Yet we see nothing. No Dyson spheres blocking starlight, no signs of stellar engineering, no directed signals beaming across the galaxy. The cosmos appears pristine and untouched by intelligence. Consider also the timescale of galactic colonization. If humanity developed generation ships, massive vessels capable of sustaining a population for 1,000 years as they travel between stars, we could theoretically colonize the entire Milky Way galaxy in approximately 2 million years. That sounds like an incredibly long time from a human perspective, but it's nothing compared to the age of the galaxy. 2 million years is less than 0.02% of the galaxy's age. If any civilization had decided to expand across the galaxy, even at speeds far slower than light, they would have had billions of years to accomplish it. Every star system could have been visited, every habitable planet colonized or at least surveyed. The galaxy should be full of evidence of ancient or current civilizations. But it's not. This is the heart of the Fermi Paradox. So what's going on? Scientists and philosophers have proposed numerous potential explanations, which generally fall into categories called filters. In this context, a filter is a barrier or challenge that prevents life from arising, surviving, or becoming detectable. These filters can exist at different stages in the development of life and civilization, and understanding where these filters might be is crucial to understanding our own future. The first possibility is that the great filter lies behind us. Perhaps the emergence of life itself is far more difficult and improbable than we realize. We know that life appeared on Earth relatively quickly in geological terms, emerging within the first billion years after the planet formed. This might make us think life arises easily whenever conditions are right, but we have a severe sampling bias. We exist, so naturally we observe a planet where life arose quickly. We can't observe all the planets where the right conditions existed, but life never emerged. The origin of life remains one of biology's greatest mysteries. We don't fully understand how non-living chemistry transforms into living biology. The jump from simple organic molecules to self-replicating entities is enormous. It requires the right molecules to come together in the right concentrations, at the right time, in the right environment, and then those proto-life forms need to survive and evolve. Perhaps this process is so improbable that it's only happened a handful of times in the entire galaxy, or even just once, here on Earth. There are other potential early filters too. Even after simple life emerges, the jump to complex multicellular life is another massive hurdle. Life on Earth remained single-celled for billions of years before complex organisms evolved. The development of intelligence is yet another filter. Intelligence as we define it, the capacity for abstract thought, tool use, and technological innovation, is remarkably rare even on Earth, a planet teeming with life. Among millions of species that have existed over billions of years, only one has developed the kind of intelligence that leads to technology and civilization. Perhaps we've already passed through multiple incredibly narrow filters, and we're among the first or possibly the only intelligent technological civilization in the galaxy. If this is true, it would mean we're extraordinarily special, and our existence is a profound cosmic rarity. This is actually the optimistic scenario, because it means the hard part is behind us. The second, far more disturbing possibility is that the great filter lies ahead of us. This hypothesis suggests that while life, even intelligent life, might be relatively common in the universe, there's some barrier that prevents civilizations from becoming long-lasting, galaxy-spanning entities. In other words, something destroys advanced civilizations before they can make their presence known across interstellar distances. This is the nightmare scenario, because it means that while we've successfully navigated the early challenges of emergence and evolution, we're now approaching the truly dangerous phase of our existence. What could this future filter be? One possibility is self-destruction through technology. As civilizations advance, they gain access to increasingly powerful technologies. Nuclear weapons are an obvious example. For the first time in human history, we possess the capability to render our planet uninhabitable. We came frighteningly close during the Cold War, and those weapons still exist today, pointed at targets around the world. But nuclear weapons might just be the beginning. As we develop more advanced technologies, artificial intelligence, synthetic biology, nanotechnology, we're creating tools of immense power. Perhaps there's some threshold, some technological discovery that seems incredibly beneficial, maybe unlimited clean energy, or the ability to manipulate matter at will. But when activated, it has catastrophic, unforeseen consequences. Imagine the last words of every advanced civilization echo across the cosmos. This new technology will solve all our problems. Now watch as I activate it. Another possibility is environmental collapse. Perhaps any industrial civilization inevitably depletes its planet's resources or damages its environment to the point where complex life can no longer survive. We're certainly testing this hypothesis ourselves right now with climate change, ocean acidification, and mass extinction events. Maybe the very traits that allow a species to become intelligent and technological, curiosity, the drive to expand and consume resources, the ability to reshape the environment, inevitably lead to ecological destruction on a planetary scale. There's an even more unsettling possibility. Perhaps there's an ancient, incredibly advanced Type 3 civilization out there that actively prevents younger civilizations from advancing too far. This idea, sometimes called the dark forest hypothesis, suggests that the galaxy might be filled with civilizations, but they're all hiding, staying quiet, because making your presence known attracts the attention of something dangerous. In this scenario, advanced civilizations might monitor developing worlds, and once a civilization reaches a certain threshold of technological capability, perhaps when they're on the verge of achieving faster-than-light travel or some other capability that could make them a threat, they're eliminated. According to this hypothesis, the silence we hear isn't because no one is out there. It's because everyone is hiding or has been silenced. There's also the possibility that we're simply not listening correctly. Maybe advanced civilizations communicate using methods we haven't discovered or can't detect yet. We're searching for radio signals because that's the technology we know. But a truly advanced civilization might have moved beyond electromagnetic radiation entirely. They might communicate using neutrinos or gravitational waves or quantum entanglement or some physics we haven't even discovered yet. To them, using radio waves might seem as primitive as using smoke signals seems to us. We could be swimming in a sea of alien communications and not even realize it because we don't know what we're looking for. But there's one final possibility we need to confront, perhaps the most profound one of all. Maybe we truly are alone. Maybe Earth is the only planet in the entire observable universe that harbors life. As of this moment, despite decades of searching, despite sending probes to other planets and moons in our solar system, despite listening with sensitive radio telescopes for signals from the stars, we have found exactly zero evidence of life beyond Earth. Not a single bacteria, not a single radio signal, not a single technological artifact. The universe appears completely devoid of life, except for us. This possibility should shake us to our core. If we're alone, if Earth is the only oasis of life in an infinite cosmic desert, then the responsibility we bear is almost unbearable. Every species that goes extinct is not just a tragedy for our planet, it's a loss to the universe itself. If we allow our civilization to collapse, if we render our planet uninhabitable through war or environmental destruction, we might not just be ending human history, we might be extinguishing the only light of consciousness in the entire cosmos. Life itself might vanish from the universe, perhaps forever. The delicate chain of chemical reactions that led from simple molecules to single cells to complex organisms, to conscious beings capable of contemplating their own existence, that entire 4 billion year evolutionary journey might come to an end, and the universe would return to being an empty stage with no one to witness its beauty. If this is our reality, then our destiny becomes clear. We must survive. We must venture beyond Earth, establishing settlements on other worlds, ensuring that no single catastrophe can eliminate all of humanity. We must become the first Type 3 civilization, spreading life and consciousness throughout the galaxy and perhaps beyond. We must keep the flame of life burning until the universe itself winds down into its final state of heat, death, trillions upon trillions of years from now. The stars, the galaxies, the vast cosmic web of structure spanning billions of light years, all of it is too beautiful to exist without someone to experience it, to study it, to stand in awe of it. So where does this leave us? The Fermi Paradox remains unsolved. We don't know if we've passed the great filter or if it awaits us. We don't know if the galaxy is empty or filled with civilizations hiding in the darkness. We don't know if we're the first or the last or the only. What we do know is this: we exist, we're conscious, we can contemplate these questions, and that makes us cosmically significant, regardless of whether we're alone. The universe has given us this moment, this chance to look up at the stars and wonder, and perhaps someday, to reach them. Whether we're the first chapter in a vast story of galactic civilization or the only chapter ever written, our story matters. The silence from the stars isn't just a scientific puzzle, it's a call to action, a reminder that our existence is precious and fragile, and that the choices we make in the coming centuries will determine not just the fate of humanity, but possibly the fate of life itself in this vast and ancient universe.